All right. Um, Today we're going to talk about the graphs of secant and cosecant functions. So it's important to remember where each of these functions come from. So if you remember, secant of x is really defined as 1 over cosine. It's the reciprocal. So 1 over cosine of x. So because it's defined as 1 over cosine, we look at the graph of cosine to begin with. So the graph of cosine of x, I'll add some colors to this and then I'll take it off. But this graph here is the graph of cosine of x. So you could start by just graphing cosine of x. And then a function or a fraction will be undefined when the denominator equals 0. So 1 over cosine of x, that will be undefined when cosine of x equals 0. Well, if we look at this, and so we've graphed cosine, cosine equals 0 anytime it has an x-intercept. So at each of those points there would be where cosine equals 0. That means that secant of x is undefined. This leads to us having vertical asymptotes at each of those points. So here at pi halves, because cosine equals 0, secant of x is undefined. It never actually touches that line. It'll approach it, but it won't actually touch it. 3 pi halves, cosine equals 0, so then there's an asymptote. So the graph of secant has a vertical asymptote anytime cosine equals 0. And again, that's because secant is defined as 1 over cosine, and it's undefined when the bottom is equal to 0. So cosine equals 0 each of those. That gives us our vertical asymptotes. Your vertical asymptote, the way you write the equation, is the first value is wherever you have your first vertical asymptote. Well, notice our first vertical asymptote is here at pi halves. It's the first time it happens, or you really could pick any of them, but this is kind of the standard way to write it. So pi halves goes first. And then this value, the k is just k integers, so you could add pi, add 2 pi, 3 pi, 4 pi, or subtract pi, subtract 2 pi, and so on. So pi, where we got pi from was the distance between. So pi is here because the distance from one asymptote to the next asymptote is pi. So that's why we'd have pi here. If the asymptotes were further away, if they only occurred every 2 pi, then you would have written 2 pi right there. And the graph of secant is just the darkest graph that we have here. So it's a bunch of these parabolas. So after you have your asymptotes, every max of the cosine graph, you have a parabola opening up. It's not quite a parabola because it is sandwiched between these asymptotes. It doesn't go out for forever. It is bound by that. And then at every min on the cosine graph, you have a parabola opening down. So the graph of secant is just these parabolas opening up and down. So for that reason, the range is negative infinity, because the graph goes down for forever, up until negative 1. From negative 1 to 1, there is no graph of secant, and then it's just from positive 1 to positive infinity, so the range is going to be something like that. Once you understand how to graph secant, cosecant, the same exact rules apply. So let's see if we can apply those rules to secant. Well, secant of x is defined as 1 over cosine. Let's see, I'll go ahead and do this one in green. So this is defined as 1 over sine of x. So therefore this is going to be undefined when sine of x equals 0. So a fraction is undefined when the denominator equals 0. So this is why we're going to graph the sine wave. So here is just the standard graph of a sine wave starting at 0 and then alternating between a max of 1, midline, min, back to midline. Anytime sine equals 0, so at every time sine has an x-intercept, sine is equal to 0 at 0, that's where you're going to have a vertical asymptote. Sine equals 0 at pi, so that's where you have your vertical asymptote. 2 pi, this is where we have that vertical asymptote. Negative pi, another vertical asymptote. Negative 2 pi, another vertical asymptote. So again, a vertical asymptote occurs every time the denominator equals 0. And since the denominator is sine, we just take those x-intercepts. Okay, so when we write the equation, I'm going to follow the same idea that we had on the last one. You can think of this as 0 plus k pi. We just usually don't write the 0. The 0 is there because that's the first asymptote, first vertical asymptote. If you look at this graph, the first vertical asymptote is here at 0. So that's why we're writing 0, or you could just not write the 0. There's always a k. It's k times pi or pi times k. The order doesn't matter. But the pi, remember, the reason why we have pi is because that's the distance between the asymptotes. You could take any two. They're always equally spaced. The distance between pi and 2 pi is pi. You could have done the distance between negative pi and 0, it's pi. So that's why we have the pi there. We're usually lazy in math and don't write the 0, which is why we typically would just write it as k times pi. Is every time there's going to be an asymptote. The range is the same. The range goes from negative infinity, because these go down forever. They stop it at -1, and then it goes back here. So again, in both of these cases, it's just a set of like parabolas bound by these vertical asymptotes. They're opening up at every max, and at every min, they're opening down. So if you know how to graph sine and cosine, then graphing secant and cosecant won't be bad. So let's try a couple here. The first couple questions just want us to find the vertical asymptotes, or is reminding us that vertical asymptotes occur when sine equals 0 for cosecant and when cosine equals 0 for secant. So it's just the denominator. Find where each has a vertical asymptote. So I'm going to just rewrite this. This is equivalent, since secant is equivalent to 1 over cosine. This would be 3 over cosine of 5x. So this is undefined when the denominator equals 0. So anytime cosine of 5x equals 0. So I want to think about what this graph looks like. So this is a review of what we did last week. With this graph, it's a basic cosine graph, except for that value there, that's b. So if you remember, b changes the period. So we need to figure out the new period. The new period is always the original period, which is 2 pi. Cosine normally is 2 pi divided by 5. So now the period is 2 pi divided by 5. If I graph this, I'm just going to go out 4 tick marks. So 1, 2, 3, 4. The 4th tick mark, I label whatever the period is. The halfway mark would be half of that, so the halfway mark would be pi fifths. I could figure out the other two by dividing in half, like half of pi fifths. This would be pi tenths, and it would take a little bit of effort, but I could figure that one out. I'm not going to bother, I'm just going to graph cosine. I know the cosine graph starts at 1, and it alternates between a max, the midline, the min, which would be here at -1, back to the midline, back to the max. So the cosine graph just looks like this. All I've done is change the x-axis. So we are looking for where this equals 0. It equals 0 at each of these x-intercepts. So right here, the graph of secant would have a vertical asymptote, and right here. So we need to find those two values. This one's pretty easy because it's just half of pi fifths. Half of pi fifths is pi 12 or pi tenths. So we know that. This one we have to figure out, but if you remember, it's if the distance between the tick marks are pi tenths, we're just adding them together. So we're taking the pi fifths and we're adding pi tenths. So I would need a common denominator. I times by 2. So I would have 2 pi tenths plus pi tenths gives us 3 pi tenths. So this second one here is 3 pi over 10. Those are the two times when cosine equals 0. So cosine equals 0 at those two values. So therefore, this graph of secant, this will have a vertical asymptote whenever x equals pi tenths or 3 pi tenths. Now the issue is this goes on for forever. So now I want to write that equation so that it indicates all of them, because cosine just continues. The way we write that equation, you always list your first vertical asymptote and then you add the distance between them. So when I look at this, I just need to find the distance between one asymptote and the next asymptote. Well, the difference between pi tenths and 3 pi tenths, that difference, I could just say 3 pi tenths minus pi tenths would equal 2 pi tenths, but 2 pi tenths is pi fifths. So the difference is pi fifths. So that's how I have pi fifths times k. So again, it's always that just difference between them plus k. So this would be the equation of the vertical asymptotes. So the vertical asymptotes occur in that way. Okay, let's try the second example. The second example gives us cosecant. So when I do this, first thing I'm going to do is rewrite it. So cosecant is 1 over sine, so I leave the -1 on top, so then I'd have sine of x plus pi halves. This will be undefined when the denominator, so when sine of x plus pi halves equals 0. So I'm going to graph this. I'm going to graph that function. I'm going to do it over here. So here's sine. This time period did not change, so I make my 4 tick marks, 1, 2, 3, 4, and it's still 2 pi. The reason why it didn't change is there's no number in front of the x being multiplied. So therefore, it's 2 pi divided by 1, so it stays 2 pi. Quick reminder about this pi halves. This pi halves shifts the graph to the left by pi halves. We always do the opposite in the x direction. So the original sine wave would start, it's going up to 1, down to -1. So it would start at 0, then go max, then go middle, then go min, then go middle. So here is the original sine wave. We want to take this sine wave and move it to the left by pi halves. Well, pi halves is one of these tick marks. If I take the time to write this, so the halfway mark would be pi, half of that would be pi halves. So each tick mark is pi halves away. So all we're going to do is take each point and move it to the left by 1 tick mark. So we're starting up here, then we would go midline. The next tick mark, we're at the min. Once you know 1 point, you're just alternating. So really I can just move the first point. So all I did was move this first point, got that point in place, and then I'm good. So now this graph represents sine of x plus pi halves. It's the sine wave that's been moved left by pi halves. I'm going to go ahead and get rid of this one. So there's our graph that we need. The question we're trying to answer is, when does this graph equal 0? Well, that graph equals 0 anytime the graph has an x-intercept. So it's crossing at pi halves and this one here at 3 pi halves. So those are the vertical asymptotes of the cosecant graph. Oh, shoot, I lost my negative. I have to keep this negative with the, well, the negative won't change anything, but I do need to keep it. This negative really needs to keep with the sign. So it's this graph, but when I throw a negative in front of it, it would be a reflection across the x-axis, so it's actually starting low. So it's going low, then to the max, then down and back down. So there's the graph of negative sine of x plus pi halves. So again, sorry, we need that negative in front here. So it needs to be a negative of that. Okay, but the vertical asymptotes, it's still crossing the x-axis at the same place, so it didn't change that. So the first asymptote is at pi halves. The next one is at 3 pi halves. So you could start to list them and say x is at pi halves, these are the vertical asymptotes, and then 3 pi halves, but the issue is the graph goes on for forever, so there would be an infinite number of terms. So this is why we're going to write the equation. It's always x equals your first asymptote. The first asymptote is at pi halves, so I say x equals pi halves, plus the distance between them. I'm looking for the distance between, so the distance between pi halves and 3 pi halves, well, that distance would be pi. So then I'm going to times by pi k. So this is why this time this comes out to be pi times k. It's always times k. K is just an integer, and that pi is there because it's the distance between. So again, this number is your first asymptote, and the pi is the distance between the asymptotes. Okay? All right, I think that that's the hardest part of graphing these. So let's try a couple more. I think when we actually see the whole graph, it makes it a little bit easier. So now we're going to graph secant of x over 2. So if we graph secant of x over 2, again, I'm thinking to myself, I really want to think this is 1 over sine of x over 2. So the first thing I want to do is I want to graph that function. So I want to graph sine of x over 2, which is really just more practice of what we did last week. So sine of x over 2, because the 2 is being multiplied by the x, it's changing the period. So in this case, b is equal to 1/2, because you can think of this inside as being 1/2 times x. Remember, it's always b times x, so b is 1/2. That helps us find the new period, because the rule is that we take, the period is going to be 2 pi divided by b, and b was 1/2. Dividing by 1/2, you flip and multiply, so we get 4 pi. So 4 pi is the period. It's always what I figure out first, so that I take the x-axis, I divide it into fourths, so 1, 2, 3, and 4. The fourth tick mark will be whatever the period is. Half of 4 pi is 2 pi. Half of that would be pi, and half of that would be 3 pi. Okay, I could go backwards and do the same thing. I'm going to just label, let's see, -2 pi and -4 pi, just so the x-axis doesn't get too cluttered. Okay, So that's the only change when I'm graphing this sine of x over 2 is I just had to change the period. The amplitude is still 1, so it's still going up to 1 and down to 1. I'm going to go ahead and just call this 1 so it can be spaced out a little, and this tick mark here, -1. So a sine wave, I'll graph it in red. Sine starts at 0. Each tick mark it alternates. For sine, the next tick mark is the max, the next tick mark is the middle, the next tick mark is the min, and then we're back to the middle. So there is a graph. That graph represents sine of x over 2. Okay, so then when we want to graph the original function, we are trying to graph this function. We need to draw the vertical asymptotes first. Remember, a vertical asymptote is every time this sine or cosine wave, whichever one it is, equals 0. So this equals 0 here because it's anytime the denominator equals 0, then you're going to have a vertical asymptote. So the rule, let me make this, so whenever the denominator equals 0, that's when you're going to have a vertical asymptote. And the denominator was sine, so this is why I graphed it. So then we have a vertical asymptote here and a vertical asymptote here. After you have your vertical asymptotes, to graph the original function cosecant, all we're doing is graphing parabolas at every max and every min. So at this max, there's a parabola. At the min, there's a parabola. And that would be it. So we could continue this graph if you wanted to. So I could go backwards, and to do it, all I would do is continue the sine wave. So if I can graph the sine wave, which as long as you have one point, you're just alternating. Every time the graph crosses the x-axis, you have a vertical asymptote. So we have these vertical asymptotes. And then at every max, cosecant would just be the parabola opening up. At every min, it's a parabola opening down. The parabolas are just bound by those asymptotes. So the graph is really just that green portion. So the graph of cosecant of x over 2 are all of those parabolas that I have. So now we can answer the questions over here. The period, the period is the same as the sine, so it's just still 4 pi. So the period is 4 pi. Vertical asymptotes, our rule is we list the first one. So it's our first asymptote, but the first asymptote here is at 0. And really you could choose any of them. I'm just going to choose 0. So 0 is one of the asymptotes, and then we talk about the distance between. The distance between any two asymptotes, you could choose any two. We're going from 2 pi to 4 pi. That distance between the asymptotes is 2 pi. So I'm going to add 2 pi times k. Generally, we are lazy and don't write the zeros, so it would be x equals, it's always an x equals equation, 2 pi k. So that would be my equation for the vertical asymptotes. The range always goes from -infinity to -1 unless you've changed the amplitude. Square bracket around -1 because the function does actually touch -1 in union with 1 to positive infinity. Okay, let's look at 2 more examples. I know these are kind of... Okay, so here is another example of graphing secant and cosecant functions. So it's 2 secant of 3x. So again, the easiest thing to do is let's just start by graphing 2 cosine of 3x minus 1. If we can graph this, then we'll just do all of the parabolas on that. So the first thing I would notice is this moves the whole graph down 1 unit. And I guess I should take care of the period first. So the period is always 2 pi divided by b. In this case, b is 3. So I take the x-axis, break it up into 4. The 4th tick mark is the period, so 2 pi thirds. The halfway mark is pi thirds. Half of that would be pi sixths. So I could label that, and then I could label this. It would be pi sixths more than pi thirds, which comes out to be pi halves. But if you want, and often I do, I just label those 2, and I only label the others if I have to. Then the amplitude is 2. I'm going to do the vertical shift next. Here, I guess I'll make a note. The amplitude is 2. So now I'm going to go down 1. So normally it's centered at 0. I go down 1, and this is the line. Okay, so that's been shifted down 1. The amplitude is 2, so I'm going to go 2 above. So 2 above would put us right here at 1 if I go 2 above the midline. 2 below the midline, let's see, that's -1, 2, 3, so -3. So that's the range of this cosine function. Cosine always starts at the max. So at 0, the maximum is here at 1 now since we did our vertical shift. The next tick mark, so here's the next tick mark. I go to the midline though. So I go max, midline, next tick mark. So at the next tick mark, I need to go to the min. So I'm going to plot a point right there at -3. The next tick mark, I'm back to the middle. And then the next one, I'm back to the max. So again, each of these critical points, or these like key points, are at each tick mark. The first one, the tick mark, halfway mark, the third tick mark, and then the fourth tick mark. So you end up with the 5 points. I'm going to connect these. This would be the graph of that cosine function. If you can graph cosine, you can graph secant. So the way we do this is we're going to graph all of the vertical asymptotes. This time though, because we shifted down, it's wherever the graph of cosine intersected that new midline. So our midline, so our 2 vertical asymptotes would be right here at that first tick mark and right here. So again, the vertical asymptotes are where it reaches the midline, whether it's 0 or in this case -1. And then secant, the difference is when we graph secant, instead of cosine, every max of cosine would be this parabola, and then at every min of cosine, you would have a parabola opening down, sandwiched between, and this one opening up. So there would be the graph of secant. So the actual graph, I take away cosine, is that green function. So the green function is the graph of secant. The period is the same as what the period of cosine was. So the period is 2 pi thirds. So the period is 2 pi thirds. The vertical asymptotes, remember we write the first one, so it's always x equals. The first vertical asymptote is here, and we figured out that half of pi thirds is pi sixths. So the first one is at pi sixths. And then we have to add the distance between. Well, the distance between those 2 asymptotes would be pi thirds. You can kind of just think, okay, there are 2 tick marks, and we could tell from here 2 tick marks are pi thirds. So yeah, it's been shifted, but the distance is pi thirds. So then you just say pi thirds times k. So again, first, and then this is the distance between. Okay, and then the range is just -infinity to that y value. The y value is -3 with a square bracket in union with 1 to positive infinity. Okay, we will go ahead and skip example C, but I do want to see one where we're writing the equation. So here on example 2, they've given us a graph and they want us to write the equation. I'm going to try to focus in on these key points. So this point, this point, this point, and then there must have been some points in the middle, so I want to find that midline. So when I'm looking at this, I'm going -1 to 3. Well, that distance is 4, so halfway would be 2. So the halfway mark must be here because then it's 2 and 2 in each direction. So I'm going to draw that midline. So that must be the midline, which means the equation must have a +1 at the end. So I'm going to add a few extra points at the midline. It must be there. So this, if I can write the equation of this purple graph, then I could write the equation of the green one. So at first this looks like a negative cosine of x graph to me because it's just starting at the min instead of the max. The other thing that I notice is that, let's see, the amplitude, the distance from the midline to the max and the midline to the min is 2. The period hasn't changed. The period is still 2 pi. And so since the period is 2 pi, that means b is 1. So there's nothing that the x is going to be multiplied by. And then like we mentioned, it has this +1. So all of this information gives me that y equals -2 cosine of x plus 1. So again, the negative because it's an upside down cosine, 2 because it's the amplitude, nothing is multiplying the x because it has its normal period, and the +1 because we shifted the graph up 1. That's the graph of the purple function. We want the graph of this green function, which is just all of these parabolas opening up and down. So the only difference is instead of cosine, cosine switches to secant. Everything else stays the same. So it's -2 secant of x plus 1. And that's it.